Mr. Harris here, and welcome to a new video of Unit 9.4. In this video, I'm going to talk about acid rain, its effects on living things, and the environment. Alright, before we begin, I want to clarify one very important concept. That is, rainwater is actually roughly around pH 5.6. So it's not pH 7, it is pH 5.6, slightly acidic. And the reason behind it is because of, first off, we have carbon dioxide in there. You guys remember what's the percentage? Yes, roughly around 0.03 to 0.04. Carbon dioxide will dissolve in the rainwater to form carbonic acid. And obviously, carbonic acid is an acid. So in rainwater, because you have this type of acid in it, the pH will drop slightly to around pH 5.6. So, from today onwards, let everyone know rainwater is not neutral. It's not pH 7. Rather, rainwater is naturally slightly acidic, pH 5.6. And the reason is because of carbonic acid. Right? So, how do we define acid rain? What is acid rain? So, because we know natural rainwater is pH 5.6, so any pH value below 5.6 will be considered as acid rain. So for example, pH 3, 4, 5, or even pH 5.5, that's considered to be acid rain. So let's look at some causes of acid rain. First off, power stations, vehicles, factories, what do they have in common? They're all used for burning fossil fuels, of course. For vehicles, we have car exhaust, so they all emit air pollutants. So what are some of the air pollutants they emit? One of them is sulfur dioxide, and the other is nitrogen oxides. All right, just to give you one more tip, these are actually acidic gases. So what are acidic gases? They're basically gases of acidic nature. Okay, very simple. So let's look at this diagram now. Large amounts of air pollutants, including acidic gases, are given off during the burning of fossil fuels, for example, in factories, from the vehicles, from car exhaust, so on and so forth. And the acidic gases, what were their names? Can you point out? Just now we've learned sulfur dioxide as well as nitrogen oxides. Right? These acidic gases, what happens is they react with oxygen and water in the air to form sulfuric acid. This comes from the sulfur dioxide gas, and it also forms nitric acid, which comes from the nitrogen oxides. So you will see that now there are two more acids joining to the party of carbonic acid. At first, it was carbonic acid alone in isolation. Now, he found two more friends, sulfuric acid and nitric acid. Now there are three of them present. Now just imagine, now you have three acids present in rainwater. What would happen? Obviously, the rainwater would get even more acidic. So when rainwater gets more acidic, it contributes to the phenomena of acid rain. That is how you get acid rain, basically. All right. So carbonic acid plus sulfuric acid plus nitric acid, you get acid rain. So to summarize, the burning of fossil fuels gives off large amounts of acidic gases, such as sulfur dioxide and nitrogen oxides. These gases, when they combine with oxygen and water in the air, remember over here, when they combine with oxygen and water in the air, what would they form? They would form two acids, sulfuric acid Let's see over here, they'll form sulfuric acid and nitric acid. And these in turn would lead to the formation of acid rain. All right, so I really like this diagram. You can go back and summarize it on your textbook by yourself. Remember to take notes, guys. All right, let's look at the effects of acid rain. So first off, I've already shown you this picture in the previous video. You can see how messed up the statue is because of acid rain, of course. Also, metal objects, they're prone to getting corroded. So you can see how the pipes are being corroded, rusting occurs. Apart from us being affected, humans, other living things are also being affected by acid rain. For example, acid rain increases the acidity in rivers and lakes. What does this do? This causes the environment, of course, because marine organisms, for example, they're not able to survive in such harsh conditions, right? When it's so acidic. So they're not able to survive, they're not able to reproduce, and finally they may even die. Plants as well. So does acid rain actually affect the growth of plants? Let's have a look. In this experiment, we'll find out the effect of acidic solutions of different pH on the growth of seedlings. What are seedlings? Seedlings are basically, let's say, young plants. Okay, they have the potential to grow bigger and stronger. Right? For now, let's say they're young plants. So you grab 3 petri dishes or petri dishes, however you want to pronounce it, and put 20 seedlings in each of them. And in each, you add, first one, you add pH 7 distilled water. Second one, you add pH 4 dilute sulfuric acid. And in the third one, you add again dilute sulfuric acid, but this time pH 2. Now you may ask me, Mr. Harris, how is it possible? How can you have 2 pH values of the same acid? Let me ask you one thing. Say, for example, I have C, and I want to get from pH 2 sulfuric acid, I want to get pH 4. There are 2 ways to do so. First off, I could either add more alkali, right? That is one way to increase the pH value, right? And the second way would be to add more water, because water is pH 7. Of course, it would increase the pH from pH 2 to pH 4. Now, which one would be a better choice? If I add more alkali, what would happen? If I add alkali to an acid, there might be neutralization occurring, right? So if neutralization occurs, there'll be salt, there'll be water being formed, and that is not what we want. We want to keep it, we want to remain it as sulfuric acid. So what we do is we can add more water in order to increase the pH. So in B, basically we have added more water. Hence why the pH is pH 4. Alright, and then afterwards, we'll observe the growth of the seedlings after 1 week, because in this 1 week, the lovely seedlings will undergo this process, which we're all familiar with, photosynthesis. Yes, guys, photosynthesis. Let's have a look at the results. So for Petri dish A, distilled water, the seedlings, they grew healthily, no problem, everything perfect. However, for B and C, you'll notice that for pH 4, B, the seedlings, they grow very slowly. And for pH 2, Petri dish C, the seedlings even died. They were dead, basically. That's sad. So from this, what do we know? We know that acidic environments are not suitable for growing seedlings. The most suitable environment would be a neutral environment, pH 7. Thus, acid rain may damage the plants by making the soil acidic, hence the plants cannot grow as well. So to summarize so far, Acid rain, it can cause damage to plants, metal objects are being corroded, buildings and statues are being corroded. We've learned about marble, limestone, sandstones in the previous videos. Water becomes more acidic, which causes living things, marine organisms, sea organisms, all different kinds of organisms being killed. So we can see that as acid rains have a lot of problems and issues associated with it. Right, so that's basically a quick video on Unit 9.4, especially on the effects of acid rain and its uses. Its causes. So let's now do some checkpoint questions to wrap up this whole unit. Question 1, can you put some marble chips? Can you put some marble chips? Okay, that's very funny because chips reminds me of candy. You know, the name candy as sweets and chips as potato chips. Again, I told you guys, do not confuse the word chips with potato chips. Marble is calcium carbonate. All right, don't get confused with that. So you have marble chips and dilute hydrochloric acid. In a test tube, she tests the gas given out with a burning splint. What will she observe? Okay, so this is a carbonate reacting with an acid. So we should know the word equation by now. Let me see. She tests the gas given out with a burning splint. Okay, here it is. What will she observe? So are we given options? All right, let's see the options. Question A, the marble chips will become smaller in size. Is that true? Yes, we've learned it already many times. Whenever there is a reactant, I've told you that what we've learned in these videos, the reactant would usually become smaller in size. And I've also showed you the experiments inside the video, so you can refer to those again. So for now, we know A is correct, but let's look at B, C, D. The marble chips will become shiny for B. Is it true? No, of course not. The marble chips become smaller, so this is not correct. C, the hydrochloric acid will turn milky. Is that correct? Again, no. What turns milky? This is only for lime water. So don't get confused, guys. This is only lime water. Finally, D, the burning splint will burn with a pop sound. Hey, that's correct, actually. Burning splint, pop sound? Yeah, what's wrong with that? Nothing wrong. Now, you gotta be careful. Let's go back to the question. The question is about calcium carbonate with hydrochloric acid, right? This is where you'll need to know the word equation. So let me write it over here. Calcium carbonate plus the acid. What will you get? Remember, you'll get a salt. What else will you get? Water. What else will you get? Carbon dioxide. So I want to ask you, the pop test, this pop test is for what type of gas? Yes, this is for hydrogen. Do you see hydrogen anywhere in the word equation? No. So the burning splint test, there will be no pop sound being formed because there is no hydrogen to begin with, right? So the answer is A. However, I have one more question though. Can you tell me the name of the salt being formed? So let's see how many of you guys recall. So again, we take the first name of the carbonate, calcium, over here, and we take the first name of the acid, which is hydrochloric. Hydrochloric, more specifically, we'll be using chloride. So the name of the salt is calcium chloride. All right, let's see question 2. Complete the following word equations. Oh, we have word equations. All right. A, zinc plus sulfuric acid. Oh, so this is, zinc is a metal. Sulfuric acid is an acid. What will you get? The word equation for this is metal plus acid. You would get a salt plus water. You guys remember that? No, it's not salt plus water. Faked you guys, right? It's salt plus hydrogen. Not sure how many of you fell for that, but let's see. Let's continue. The salt you get is zinc. Remember the first name of the metal, and then the second name of the acid, which is, in this case, sulfate. Then you can write down the other part, which is hydrogen. So the answer is zinc sulfate and hydrogen. All right, this should be the last one. Complete the following word equation. You have carbonate plus potassium carbonate plus hydrochloric acid. So it's just like question 1. So for the salt, you get the first name of the carbonate, which is potassium. And then you get the first name of the acid, which is it chloric? No, you have to change it, remember, to chloride. So potassium chloride plus water. And what do you get? Yes, carbon dioxide. All right. So that wraps up Unit 9.4. So I'll see you guys in the next video when we're going to start Unit 9.5. All right, that's it for now. Bye.